Hey guys, welcome back. Last part of section 3.1, and this started off with an exploration and a little bit of what we started off, and what I want to do is I want you to look at this. I'm going to start you off a little bit. I want you to look at this and be ready to talk about this the next time we come to class. Alright, so here we go. So it says suppose that the function of f in figure 3.3a, that's this figure here, 3.3a, it represents its depth in inches, so this is inches, of water in a ditch alongside a dirt road as a function of time in days. Okay, so this is in days. And how would you answer the following questions? Number one. So what is number one? Number one says, what does the graph in figure 3.3b, that's this one down here, represent? Okay, what units would you use along the y-axis? So y prime, this tells me that this is slope. So what is slope? Slope is talking about the change in y over the change in x of this graph up here. But what is y measured in? Y is measured in inches. And here it's days. So the proper way to measure this is inches per day. That's the units which you use for the y-axis. This down here is still the x-axis, okay? And this is still measured in days. All right. Next it says, describing carefully what would happen to the water in the ditch over the course of the 7-day period. So I'm looking for you guys to talk about when is it rising, when is it decreasing, okay? When is the water rising in the ditch? When is the water falling in the ditch? When is the water staying the same, okay? The next one is, can you describe what the weather is like, okay? And how does this graph help you? So I want you to look at all those questions and come back to me on Monday, okay? So, not Monday, but our next day. Next I say here, okay, so now this last one here, I want to do a one-side derivatives, okay? And how can they differ at a point? So much like our limits, when we're doing a limit, we're checking the limit from one side of a point to another side of a point, to see whether or not the limit existed. Well, we have another limit, right? We have the limit, okay? We have a limit, and I want to find the point there at that point. Okay, again, the limit as h approaches 0 of f of, a plus h minus f of a all over h. The problem is, again, this 0 down here does not mean this 0 on the x-axis. It just happens to be where that one's at. Okay, the 0 is represented here at the a. And the question is, okay, so what is the slope at that point? And what I want to do is I want to take a look. What is happening to the slope to the left is 0 and to the right is 0? Okay, so you're still going to write it as the limit as h approaches 0. Notice no left or right notation there because that 0 has no bearing on what this 0 is here. Okay, but my function is going to be different. Okay, for the one that's coming from the left, it's going to be the x squared one. So it's going to be a plus h squared minus a squared all over h. All right. And then I replace it with 0. Okay, so now I replace a with 0. And what I get now is the limit as h goes to 0 of h squared over h, which is equal to the limit as h goes to 0 of h, which is then equal to 0. So the slope at the point 0 is approaching 0. Okay, that makes sense on the left-hand side. On the right-hand side, okay, now it's going to be the limit as h goes to 0 of 2 times a plus h, okay, minus 2a all over h. And now a is 0, and I go ahead and plug that in there. Now I have the limit of 2h of as h goes to 0 of 2h over h, which is then equal to the limit as h goes to 0 of 2, which again is equal to 2. So as my slope is coming from over here, it's approaching 0. As my slope is approaching from over on the right side, it's approaching 2. My slopes do not match. Therefore, the slope does not exist at x equals 0. Okay? Got to be able to say that. So in general, if there's a sharp point or a sharp turn, okay, there is no slope. That's in general. We'll talk more about that later, but just in general, okay? But the mathematical way of saying it is that the slope from the left does not equal the slope from the right. All right, with that being said, here is your homework. I hope you enjoy. Good luck. God bless.